Okay, can you see my screen? Let me know once you can
Yes.
see my screen.
Yeah, I can see your screen.
Yes.
Can you see an architecture?
Yes.
Yes.
Okay, all right. Okay, good morning, everyone. So today we'll try to get discuss of the project that was presented last week, and also we'll try to let's break it down step by step and the all components included in it. So to first of all, we'll be discussing about the highly available web application. So the project is actually um, deploying a WordPress application on AWS, and it's not just deployment; it includes an highly available. And when you're talking about highly available, you'll be talking about your subnets in terms of your availability zone A, availability zone B. So whenever you had something that said highly available or highly scalable, when you're talking about highly available, it means that you will be talking about splitting your workloads across the region, across zones. So if you are using AWS one region, automatically you'll be deploying your infrastructures in more than two or above availability zone. And you won't be thinking of using any zonal service. You'll be thinking about regional service because of that highly available phrase that is in there. And we are talking about the scalable deployment. A scalable deployment means when something can be scaled easily. So, for example, now you know we have two type of scaling. We have horizontal scaling and we have vertical scaling. Does anyone have an idea what it means and how it works?
Yes.
Okay, yeah, we can
The,
proceed. Sure.
yeah. The vertical auto scaling has to do with increasing the size of the CPU and memory
Okay.
to accommodate the workload.
Okay.
The horizontal scaling has to do with increasing the number of nodes to accommodate
Okay.
the work, the number
Okay.
of instances. Yes.
Okay. Okay. Yeah, thank you very much for that. Actually, that's how it is. So horizontal scaling and vertical scaling. So now when you're talking about horizontal scaling and vertical scaling, so from what Ephraim just mentioned, is that Ephraim, right?
Yes. Yes.
So from what Ephraim just mentioned, that horizontal scaling is when you are creating two instances. For example, now you have only one server that is hosting your application. Maybe you scale them to two, three, four. Do you understand? That's horizontal scaling. But vertical scaling is maybe the server you are using is an 8 gig RAM. You scale the RAM to 16 gig RAM, or you increase the CPU processor. Things like that. That's vertical scaling. But when we're talking of in terms of failure, would actually go respect of horizontal scaling rather than vertical scaling. Because in terms of failure, horizontal scaling is highly available than the other guy, which is vertical scaling. Both of them are still scaling, right? But in terms of maybe one of the server just went down or it crashed or anything happens at the end of the day, you can agree with me that the whole website will be down, right? But in case of we now have maybe two or three instances that is serving the users. So that's when we now have something we call that horizontal scaling, and it is it is more acceptable because in terms of the highly available situation that's or highly available application that we are deploying. So that's the reason why when we that's how some terms and terminologies are very, very important. So if you are doing writing exams or maybe you're in an interview, those are the things like to be able to buttress your points very well for them. That's okay, at least you understand all these things. It's not like it's just like you're just speaking in terms, you'll be saying it in terms of the technical aspect as well. So that's what they mean when something is highly available and scalable deployment. So now when something is now So when we are talking about an scalable deployment, and we are choosing horizontal scaling, right? So when you're using horizontal scaling, there's a bottleneck that is going to likely happen. The bottleneck there is that it's not actually a bottleneck, but if I'm using 3 or 4 instances and people are calling, I'm expecting people to call just one endpoint, one application. So automatically, you will believe to me that I need somebody in the front that will be accepting those requests from those guys. I need someone at the front that will be accepting those requests from those guys, that will be able to share it across them. Do you understand? That's where we have the load balancer. So the load balancer is there for that purpose. So it's going to serve as a one entry to our application. So everybody from the internet will be calling the application load balancer. So when it gets to this guy will now distribute it across it. So this guy is doing like 2, 3 jobs for us. Number one is balancing the services across the endpoints, across the server, the applications. So it's not like, okay, 80% of the workload will be going to instance A, 20% will be going to instance B. No, it's going to call, we have different types of application load balancing. We have round robin, we have a lot of them, but I think the round robin is one that is common. So this guy will load balance those guys, the services across this instances. I get it. And as well, he's doing another thing called health check. So this guy will be doing an health check based on maybe the endpoints or where the users are actually calling the application. So whenever a traffic is coming, this guy will have done an health check and confirm, okay, hello guys, are you fine? Are you listening on port 8080 or are you listening on port HTTPS? Any of the ports they are listening on, this guy will have confirmed they are fine. So that ensures that it helps us to monitor the health check of the application. Assuming one of the guys will be down or the health check is on LD, so this guy will not redirect indirect request to it. It will not. It will not at all. It will not. And there's something we call stickiness. Stickiness is the means that it is it is the guy that processes the incoming will be the one to process the outgoing, so that you don't have a mismatch of your traffic or anything. So that's what we call stickiness. So load balancing also ensure there's a stickiness in which that, okay, assuming you are maybe you are doing something on your WordPress, and you are like, maybe you're updating a form or you're writing a blog on your WordPress application. You will, assuming this guy is the one that sets the flow. In traffic, there's what we call the session flow. So load balancer will ensure that this guy is the one that maintains that session flow. It will just bring it back to this other guy. So that's another effect of the load balancing and all that. So I'm just trying to explain each of those components one after the other. So now let's go to the other side. It's highly scalable WordPress. So it's going to have, these are the components of the application. We have the application server, we have database, we have file server that can scale independently of one another. We've talked about two zones and all of that. So we've also talked about the one application server, like the load balancing and all of that. So now let's talk about the database. So the database is actually to store the user's records. It's different from the application data. It's two different things. Database here is actually storing the user's record. Maybe it's the record, the ID, or maybe the content of your article and all of that. So that's the database is working for. But the file server is just like, how will I call it? Your network, maybe your company, you have something we call like a file share. Let's say something like a OneDrive. You have a OneDrive that everybody can copy something from. It's just like a shared drive. I get it. That's the file server. So this file server is responsible for running the application. Everything the application needs to use to run is on the file server. So in case, and there's a reason behind this, is that in case one server, assuming somebody asked this question last time, assuming we're using EBS, EBS is only local to an instance. Elastic block storage. Are you getting me? Elastic block storage is just like the hard drive that you put to your laptop. Something like an hard drive that you put to your laptop. It's local to your laptop. If there's an issue or anything happening to that zone, your laptop is done. I get it. But assuming you are using a file storage, a file storage is just like a shared drive. So all the application servers, they pull the application data from it. Everything that your server needs to come up, include your application data, the website settings, and all of that. You know the application data now, how the website is going to look like. So this is what is on this EFS. We call it elastic file storage, and it's a regional service as well, which actually confirms to the point that we are using an highly available service. So now, on the database, I said that it's going to store records of your application. That's the database, your application data and your blogging that you're doing. And this is a WordPress application. You can use it for anything you feel like you want to do, or you have an application. So this guy, it's going to, we have on AWS, we have what we call a managed database. That's called RDS. RDS, in RDS, we have two. We have Aurora, which is the AWS native database. I get it. And we have the other ones. You have the MySQL. We have a lot of them. I'm going to show it on my screen. But in this something, we are going to be talking about MySQL, something like that. Yeah, RDS. And we're going to see how MySQL is the most popular one. And MySQL is a relational database. So we are not talking about non-relational. Non-relational is the one that we used for our API gateway. That's DynamoDB and all of that. That's non-relational. They call it key value database. You understand? So, but this one is a relational database and it's RDS. So anything relational database, it goes to Aurora RDS. Anything non-relational, it goes to DynamoDB, like that. So that's all about the architecture. That's all. So now let's see the flow. Users from the internet coming in. Can everyone hear me? Am I audible?
Yes, we can hear you.
Okay. So everybody coming on from the internet is around 53. Going to get there. Yeah, we might not get here. Yeah, it's a very deep topic actually. Very, very deep one. So Route 53 is just like your DNS. Yeah, cloud fronts, just to have something very close to your users so that the traffic will not be getting to Europe. So it should have the essence of this guy is to have a very low latency for your customers so that they can easily access your website anywhere they are all over the world. Maybe they are in China, they are in Australia, they are in New Zealand, all of that. So that's the essence of cloud fronts. People have the cloud fronts in Nigeria. Yeah, Facebook also have. I think they have an MTN and all of that. So cloud front is very, very important. So now these guys are outside. These guys are global service. That's another thing I want you to pick from is architecture. In this case, we are talking about global, regional, and zonal, right? So this guy is a global service. You can see they are outside. They are not inside the region. I get it. They are not inside the region. So now these guys are global services. Now let's come to the VPC. VPC is a regional service. So in the VPC, this is your internet gateway, right? So because we are doing highly available, everything is going to be 222. So we have our application load balancer that push the traffic to these guys. So we are going to have like 30 subnets. Can someone tell me the essence of NAT gateway here? It's a NAT gateway here. What's the reason why we have NAT gateway here?
The NAT gateway is to enable the private subnet to have access to the internet in case it wants to download updates.
Yeah, exactly. So, yeah, thank you very much. Thanks a lot, different. So, this NAT gateway, this guy is there to ensure that this guy is a WordPress application. You might need to do sudo apt install WordPress. You might need to install the packages and all of that. So instead of going through the internet gateway here, you don't need it. This NAT gateway will just take you like this, and you go to internet straight up. So anything here, these guys will have access to internet, and you'll be able to do anything you want on the application subnet. But because these guys we're using a managed database, you don't need to go to the internet because AWS is managing it for us. These guys, they are managed database. We don't need. That's why you can't see them connect talking to the NAT gateway. It's only these guys, this WordPress instance that needs to get to the internet. that connecting to the NAT gateway. And we have our auto-scaling here. And you can see that this EFS also is within the region. So it's a regional service. For all these guys you seeing internally here, they are zonal service. You place them in a zone. You place them in a zone. So that's all about the architecture. I think you will understand this architecture very well. Or is there any question around it? I don't know. Can everyone hear me? Are we together? Hello? Are we together? I'm not hearing anything. Is it my mic?
I can hear you.
Yeah, I can hear you from
Uh,
my end.
so yeah, I actually expect you to just give response. I just so that I know that we are all together, we are following as well. So this is how the architecture looks like, and this is all what is about. So now from this architecture, we can see that we're going to be creating how many subnets. I want it to be interactive. Let's move fast. We are going to create how many subnets from this architecture?
3 subnets. Sorry, six.
See?
Six.
Yeah, we created six
Six.
subnets, right? Yeah, exactly.
Mm.
Six subnets. So six subnets, two for data, two for application, and two
Mm-hmm.
for public. So this public, this guy is going to be where our NAT gateway will be hosted. You know, you want to create your NAT gateway, put it on a public subnet. This guy is going to be on the private subnet, while this data is going to be on the data subnet. So now let's start. So this is the application, and then this is the lab. Let's just come to it. So ideally, I will all agree together before. The foundation is the network. The network is the foundation. I get it. So that's very like there is no architecture you will do on cloud today. You need to put the network at the front because that's like the backbone of anything you are doing. You need to understand okay the flow within your VPC, outside your VPC, and all of that. So we both agree that we have a VPC here. We have a VPC here. We're going to create a VPC. We're going to create one internet gateway. We're going to create two internet gateway. We're going to create three subnets. Are we getting? So now that's our architecture. So we have two A's, maybe EOS 1 or EOS 2. We're going to create six subnets. And we're going to create one internet gateway and two NAT gateway. So this is just like an overview of everything. This is just, can you see? This is just the overview of everything. So let me log into my account.
I hope my screen is visible to everyone.
Where is my MFA?
Yes, honestly.
268191. Okay, so let me go to my region. This is where I plan to do this. So I think I've done this lab before, so I think I have some fundamentals of it, the foundations of it here on my VPC because of time. Okay, so this is my VPC. So the interesting part of it is that you can still use Terraform to create all of this. from the beginning to the end. It's well, I'm coming on. Where did I put it on? Let me try US61. It's not here. Okay, so this is the VPC. So you can see. So this is the VPC. And in the VPC, can come to the resource map. I've put the VPC already. This is the VPC. So here's the VPC. On the VPC, we have 6 subnets. We have the public subnets, data subnets. So on the route table, we have a route table. You know, we can all believe that this is the default route table, right? That comes. So this is the public route table that goes to the internet. This is the route table for the NAT gateway. And these are the 2 routes for the NAT gateway, right? So we'll all agree to that. So this is the old 3 subnets. We need to create a NAT gateway. So now let me create a NAT gateway. Because of cost, that's why I deleted my NAT gateway before. So let's create WP.
Sorry, Shlamon, just to mention,
Yeah.
the VPC you created, it's basically for this lab. Am I correct?
Yes.
Oh, okay, just to further buttress, if you create VPC and you don't delete it after use, it doesn't incur any cost. Is that?
Yeah, it doesn't. What
Okay.
actually take cost is your internet gateway, your NAT gateway. I get it.
Okay. So
Your
if
internet
I create
gateway,
VPC, I
your
don't have
NAT
to
gateway.
delete it.
Yeah,
Okay.
Your internet gateway, your NAT gateway, and your elastic IP. Those are the guys that chop money very well.
Okay. Thank you very much.
Yeah, you're welcome. So, you know, I said we are putting NAT gateway inside the public subnet, right? So now we all agree to it. We all know the reason, right?
Yes.
I think we've explained it earlier. So now let's before you can't create the NAT gateway without an elastic IP. You need an elastic IP to attach. So you just allocate an elastic IP. Once you allocate, and that's all. Public subnet it creates. So same thing as well. Let's create another one. WP NAT gateway. It's B. So because we take the second subnet, public subnet B, we allocate an elastic IP, and we create NAT gateway. So our route tables. So route tables, you can see that in the route table we have that's where we have our routing. That's where we explicitly showed our routing. So we all believe that in the public subnet, in the public route table, what are the guys that needs to be there? The default gateway, right, that goes to the internet. This one is a local, is always there. So the subnet association, we associate the public subnet there, right? We all agree with that. So now let's go to the NATs. So the NATs, what's going to be here is going to be what we need to call to the internet. Because I've created one before, that was why this guy I've deleted it. So that's why it's showing a black hole. So I need to come here again and update it with the new NAT gateway I just created. So let me just remove this 0.0.0.0. That's the default route. NAT gateway. Which one am I? Route table A or B? Okay, it's A. So I come to the routes, edit the routes. This one was black hole because that was the previous one. That's why it's showing black hole. I doesn't know how to get there. NAT gateway. NAT gateway. The pick W NAT gateway A. I still change this. That's it, right? So what are we associating to it? We're associating the guys that need to speak to the internet without using the internet gateway. And who are the guys that need to speak to the internet without using the internet gateway? The guys that need to is actually the what? They have subnets.
The
These guys.
WordPress.
So these guys will be the one that will be, yeah, they are the WordPress instance. These guys are the one that will be associated to the route. So let's move. Where is my account? So let's edit the second route table as well. Let's edit the route. And I told you black hole because the guy was not there. So let me add the routes, default routes, and NAT gateway, and we choose B and we save. So what you can see that the subnet that are associated to it, application subnet B. Do you know why it is B only? Any reason? Any reason why it is B? Why didn't we do the associate A to it? We just associate B only. Why?
We want to have redundancy. We want to have a separate routing table.
Exactly.
I
Because
think separate routing table.
exactly based on the high availability stuff. So and this guy, it's this guy is per availability zone. The NAT gateway. NAT gateway is per availability zone. So we're going to have one on the A side and we have another one on the B side. So we are through with the route table. I think everything looks fine from here. I think let me delete this one. So let me leave it. I don't know. Once you create an VPC, there's a default route table that comes with it. So ideally, sometimes you delete it or you just leave it the way it is, since we are not just associating any routes to it. Okay, let's go back to this guy. So we've done this, we've created an internet gateway and all of that. So we've done the NAT gateway and we've done our routing. So this is what we should have at the end of the day. So let's go to the resource map. Go to the resource map. We'll see that this is what we have. We can see this is what we have at the end of the day. So if you go to the routes, you can see that the way it links together, you will see all your associated components. Application subnet A is in the route table here, and it's linked. So this guy will show you how everything links up together. And I think we are all good on that. So now we've done the foundation. Now let's build the data here. Now there's something they try to do about security group here. I told the security group is actually a kind of an instance control, instance level security measure, whereby you can do on ports and you can do on you can whitelist on inbound. I told you that outbound is free, right? Outbound is default, but inbound you need to specify, okay, this particular port I'm going on the inbound. But in this lab, they are trying to reference a security group inside another security group. So instead of using the IP, instead of maybe you don't know the IP or you don't actually know the IP that you're going to use at the end of the day. So once you reference a security group in it, it's going to automatically put this guy up. So now let me show you this thing. So now this guy was saying we have two database clients to be attached to the EC2 instance running the web servers, right? The database needs to speak to the what? They need to speak the instance, the EC2 instance needs to communicate to the database, right? We all agree to that.
Yes.
Yeah, and MySQL listening on port 3306, right? So what happened is that we're going to have two security group. Number one, we're going to have the database client and the database itself. And this is the logic behind this guy. So this is the database client. Database clients, you don't put anything there, just create it normally. That's the database client. That's what you're going to associate to the, because the database client is a EC2 instance. Don't get it wrong. The database client is the EC2 instance. The database is what you want to attach the security group into. Let me come here. Let me come back here. This is your database client. This is your database, right? So database is an instance control level. It's a port level security, right? So what you're going to do, ideally, security group should be, okay, oh, let's pick a security group on this database subnet for database and open it on port 3306 from the instance of this guy. Are you following me? Or is it confusing? Are we
Yeah,
together?
we are following, but I know that I had that challenge. We had that challenge when we were doing the lab, because I was wondering that why do we need to create two because the first SD, nothing, we did not open any ports. So I was like,
exactly. Exactly. I knew that you guys, yes, I knew that, yeah. This is the reason actually. It's a very logical reason. And you see that at the end of the day, you agree to me that it's very, very important. Because ideally, this database should be the one that, okay, let's create a security group database, attach that security group to that database, and open it on port 3306. That security group should be, let me just come here. Let me come to, so that we would all agree. We all see what I'm trying to point out.
okay.
Let me do as if I want to create a new security group. So ideally, this is how security groups look like, right? So when I say, okay, if I want to assign it, for example, I want to assign it to an EC2 instance, I will say that, okay, well, let me allow port 22, and I'll put my source IP here, right? That's the normal way. So, but now we're talking about, okay, we are talking about MySQL, that's 3306. So ideally, I should put the IP address of the guy that needs to access me on port 3306, which is database, right?
Yes.
But the interesting part is that in security group, you can reference more than IP, can reference a lot of things. Now, if you come down, you'll see a lot of things that we can reference. We can reference IP, we can reference security group.
Okay.
We can even reference previous lists. So now something is that this guy, you can reference, so this guy needs to be open on port 3306, which is very, very fine, right? We all agree. And this security group should be attached to my database. But why is the one we are creating, why are we creating the one for clients? At the end of the day, the one we are creating for clients is we just attach it to the EC2 instance. It's just like we are using, so once we attach that security group to that security instance, we don't put anything there, we delete it. Nothing is there. So automatically, it's just as if security group, the EC2 instance is the one that wants to access the database. I don't know if you understand my explanation.
Yes.
Like what they did there is that they first create what they called database client. Database client, you just create it. Nothing was there. Did not add any rule. This is just like showing you that this guy is like an entity, is just an ID, a security ID for application instance. The EC2 instance that wants to access your database. You now created another one that you will now, okay, add a rule, port 3306, MySQL, and you're all going to be your source. Your source is going to be the security group you've created, which is the database client that you have created. That'll be your source. I don't know if you understand my explanation.
Yes.
So it's just as if in this one, it's just as if we are trying to put the IP address of the database of the EC2 instance that needs to access our database. That's what it looks like. But instead of putting the IP address, the IP address might change, anything might happen, but just to make it more kind of logical in terms of referencing, they will just reference the security group of the client. And there is nothing in that security group. There is nothing at all. Let me take you come here. Come on.
Just so I comment.
Okay.
Does that mean that the security group does not change if it's not deleted? So if it's not deleted, that means that the identity will be tied to it, more like you are tying it. unlike the IP address that, I mean, it can be altered and it changes. Is that?
Exactly. As far as you attach that security group to that instance, it's just going to pick the identity of that security group like that and put it in the other reference row. So now let's check it. This is W. This is the first one, the database client. You can see this is database client, right? Inbound room, there is nothing there. Outbound room, this is how it looks like by default. You can see that the inbound, nothing is there. Nothing is there at all. Nothing is there. So when you now come to the database, this is the database. So let me edit. So we'll see that in this guy, what was referenced? We referenced, DA90. Just check the last ID. Let me remove it. Let me come here, DA90, and come back here. So what I'm referencing here, what they reference, this guy, they opened it on 14306. And ideally, this guy should be on our what we want to access. The guy that is listening on 14306. That's our database. Database is the one that is listening. So the application is coming. They want to get the data from the database. So now, who is the source that wants to speak to the database on 3306? Instead of putting the IP, ideally you will have put 10 or 2 or something. Or no, we don't need it. Just put the security group that you've created that you want to attach to your EC2 instance. Just put it there. Automatically, it's going to reference that EC2 instance. I don't know if I'm communicating. So I will just pick database. You can see database client DA90. That's the last ID. Just pick it up and save rules. Since I'm not even making any changes, so that's why it is nothing. But the reason I'm going through this is just to explain the reason around all these. They will see it very, very well where they will reference a security group inside another security group. If the reason is actually because they don't want to start from putting IP address. IP address might change. A lot of things might happen. But the security instance, the identity of the security ID on it will not change. So same thing goes to the NFS. The NFS, which is network file storage, the network file storage is the NFS, that's the EFS storage. We are the server is the client. You want to access it on ports. I can't remember the port, I find something. So the EFS should be the one that should attach that security group to it. So we'll create two things. We are going to create the client. The client, EFS client, nothing will be there on the inbound because it's not the one that is listening. It's not the one that is listening. But if you come to the EFS itself, you will see there will be an inbound security group. It's the NFS 2049. Who is the source? Who is the source? The EFS client, which is this guy. So that's what they call a kind of a referenced security group. This, I don't know. I'm able to explain very well. Do you have any question around this? Or
It's clear.
Are we
I think
together? Let me see.
trying to explain. It's very clear.
Okay, good. So good. So that is the logic behind all the security groups. So you'll be wondering, how like a security group, they not put any inbound rule there. Don't worry, that's the reason behind it. So you create the security group and all of that. So the next thing, we're going to create an RDS. I told you that RDS is a managed security database. It's a managed database, so it's not like you need to install MySQL and all of that. So you don't need it. You have everything there already. So let's create the database. So you just have to come here. You click on database. This is Aurora database. I've not even deleted it. Oh, this is not drop my money. Oh. Let me delete it now. because I want to show you something about this guy.
Oh, that's like what you did not set alarm.
I actually so set alarm. Only because I have credit share.
Okay, just so I wanted to ask him. Can you hear me?
Yeah, I can hear you. I can hear you.
Okay, so I just wanted asking, for how long will you put up an instance or maybe a RDS or whatever instance or whatever thing resource that's, I mean, for how long will you have to stay before they start billing, before they start throwing you charges?
You know, the billing, the billing are different. Some bill per hour, some bill per month. Some bill per hour, some bill per month. So majorly is the hour billing. This instance is per hour, and some other services are away, and some other services are even per call. For example, like Lambda is per calls and all of that. So, but this instance is you know, if you create this instance, you are costing for two things. Number one, you are costing for your EBS storage, and that's one is the number of gigabits per month. And you are costing for your EC2 instance. So your EC2 instance is per hour, but your EBS storage is per month. So they will now sum everything for you across and give it to you at the end of the month. That's in the month they bill you. So they bill you at the end of the month.
Okay, so my reason for saying that is probably when I'm practicing, or I mean, any other person here is practicing, and maybe you spend 2-3 hours trying to practice, and your RDS is on, or maybe your instance is on for those 2 hours. Well,
Yeah,
okay. Thank you very much.
for those hours. But the ideal thing I really advise is once you are done with your lab, clean up. Don't wait. I don't know why. I actually forgot this guy, Sha, but you can see that there is no instances there again. So I've did the instance there, so they won't bill me. I mean, on Saturday, last week, I saw like $20 or $35 on my billing.
Hey.
But you guys, you can apply for free credits. It's available. You can apply for it. At least it won't but the only thing is that you need to create an account first before you can apply for a free dollar credit. So why this guy is still popping up? Let's create the EFS.
Please, where can we apply for credits, please, sir?
I'll drop the link on the
chat. Created. All right, thank you.
I'll drop it on the chat. So now let me now give all of them. Why are all of them taking time? So EFS, you guys, as I said, like your shared file system, something like your network file storage, where everybody will just pull. So then sometimes we call it wak. Okay, let me wak to the server. Just from there, you pick your file or anything you want. So now let's create a file system. Let's call it you create the VPC. Or let's follow let's follow this thing so that I won't break. Let's follow this thing so that everyone wants to do it at home. So now we have RDS subnet group. So RDS, actually is a managed service. But notwithstanding, you need to create like your subnet, your VPC, where you want it to be hosted. So that's why I said network is still the fundamentals. There is no how you will come across it. So you need to create the RDS subnet group. So in terms of the highly available stuff that you need to do. So when we come to database, database, you come to subnet group. Yeah, I'm with you.
Okay, I'm sorry. I just want to. It might not be within the scope of this class, but I just want to raise it. Okay, so for an instance, let's say you mentioned wak, and then I just thought about it. That let's say you want to have a backup, maybe a database backup. You just want to be backing up database, and backing up database means that okay, you need to have a repository somewhere that you can, maybe NTFS. that you can did I say NTFS? Sorry, FTP, that it can be, you know, putting the database into. Is it possible that you probably from your own premises, if you have your own premises environment, is it possible that you
Okay.
do that to maybe E3? Did I say the S3 rather? Is it possible? Is it?
Yes, you can do that. You can use maybe when we're talking about S3. So S3 is that guy is he can take anything as far as the data, he can take anything. So the only thing you have to do is just to like create maybe a cron job or something that will push your data maybe weekly, monthly, and download it to an S3 bucket. You can even specify the directory paths you want to be uploading it, maybe monthly, weekly, and all of that. So S3 can do the job. Even the
All right,
snapshot
thank
that
you.
is created here, you can see that exports in S3. So your backup of your database here is actually in an S3 bucket. So when you back up a database here, AWS is not showing where they put it, but automatically it's in S3 bucket. So that's
Thank you
just
very
it.
much.
So this is the you're welcome. So this is the subnet group. So if I click on it, I've created this guy before. So you can see that the subnet group, these are the availability zone. So this database will be present in this availability zone. We have the data subnet A and data subnet B. We have them already. No EC2 instance at all. No security group for now. This is just subnet grouping. And if it is only one, we put one there. So let's create our database. Why is this thing slow like this? So this is just the steps and all of that. So from you can see that the database we are creating is Aurora. Aurora means is a managed RDS. Aurora is the way Google has their own, Microsoft has their own. So Aurora is just like a native name for AWS, but it supports a lot of you can create different types of engine. You can create MySQL, Postgres, Oracle, and all of that. So let's create our database. So standard create, you're going to pick standard create, you're going to put Aurora because that's what you want to choose. Aurora MySQL compatible because it's managed. If you choose Aurora, AWS is going to manage everything for you, include both patches, both upgrade and everything. But if you choose MySQL, you'll be doing your thing by yourself. So this is the MySQL engine, that's 8.0. So we're not using the production template, we're using dev. So the database cluster, WordPress, let's give it one name. WordPress workshop. So and we are using standard, right? We're not using IO. So can you see these guys? See, these guys are expensive. 16 gig RAM. I don't think I have money to that extent. So let me just choose bulk table. Bulk table are the T2 ones. When you have instances of different classes, we have the memory optimized, we have the compute optimized, we have the normal medium one, we have GPU optimized. So I think there should be a table or something that shows how those instances are. So the T ones are the T2 micro we always use. So those ones are still affordable. I get it. So you can use the one affordable. Let's use the one they use in this lab. I think they use. Let me see the one they use. Yeah, T4G medium. I think that one is still fine. That one has 4 gig RAM and 2 vCPU. So I think that one is still just something. I think this is right. Yeah, This right. This looks nice. So now because we are using an highly available, so we're going to something we call read replica. Read replica means that, how would I explain it though? Let me create it first. I'll explain it. Let me create it first. I'll explain it. I'll explain what this read replica means. Read replica means that, database has instead of in database we have two operations that we normally do. We have read and write. The read and write, instead of reading from the same instance where you are writing from, so AWS can create a kind of a read replica so that your application will be able to you have very high retrieval output. So instead of writing and reading from the same instance, you'll be writing to a different instance and reading from a different instance. You're going to automatically switch it for you, and that will be very, very fast. So I think all of this is just to ensure you have a very fast communication IOPS between your EC2 instance and your database. So let's change our VPC. These are VPC. Security group is created, right? Public access, no, we are not doing a public access. So I choose the existing one. So which one are we choosing here? Which security group are we choosing here? Anyone?
Web servers.
Are we all together?
Database clients.
Why is web servers? Malik, why should we choose web servers?
I'm sorry, that was a mistake from my end. It's not web server. I remember that web servers are for applications for the load balancer and then this thing.
Yeah, exactly.
DFS clients.
So let's choose the WD database. So I think we've explained this before. So I've not seen our client though. I'm the one that I didn't pick it. So this guy is important. Credentials. Let's choose what they put there. WP admin. So your password, you can manage it with Secret Manager. Yeah. And you can use your own password. So this is password to the instance. This server instance. Someone should use it. So this is what's my password? Password 1, 2, 3, 4, 5. That's my password. Password 1, 2, 3, 4, 5. Please, if you mute. Malik, you can mute your mic. So we're creating a database. So these credentials, you can actually pick, you can reference your secret manager. That's an AWS service that helps you to manage secret passwords, or you can just use a self-managed, something that you can remember. So this is like logging into the instance. This is the database instance. Database instance is different from the database itself. For example, they give you a server. They give you a server, you need to install database on it. So once you install database, you now need to log into your database. The way you do MySQL, this thing, to connect to your database. So it's a different thing. So let's continue. Let's continue. I think I've created my database and I've chosen my instance. That's my server. I've chosen my VPC. I've chosen my subnet group. Okay, let's check additional configuration. So this 3306, that's the ports it's using. Standard. So these are enhanced monitoring. I think I'm not creating that one. So this one depends on you. So let's go to additional configuration. So yeah, database name. So this one is now your database name itself. I get it. So it is, it's a different thing now. The first thing we create was your database instance. That's your instance, the server. So you now to create the database name. That data, in that database is where you now create your table and all of that and all of that and all of that. So let's give it a name. Let's give it WordPress. So kind of priority, you have we don't need it, and encryption. That's KMS. That is the default one. Link. Everything looks fine. So everything looks fine. So to figure how much you'll be. So this the guys that is an estimated monthly cost. That's about $3.29. That's great. So at the end of the day, this guy is going to create two things for me. Is when you create my writer endpoint and my read replica endpoint. So my writer endpoint is what I'm going to reference in my application. So AWS will know how the read replica will be used. So the writer endpoint is what you put in your application. So it's automatically now we've sent your this thing to your read replicas. So you can see you'll be seeing that read your instance and so let's it might take some while for you to create, but I think we've finished. We are through with the database. So let's create the next guy. So we create our EFS. I said EFS is just like yeah, the security groups. I think I've explained this as well. And so the next thing, the EFS is very simple. So let us create. Let me copy this name here. EFS is just like a network file storage. So you put the name, you put the database, then you put the security group, and yeah, you put customize because you need to put your security groups as well. Let's see additional settings. Yes. So this is right. So this is the WordPress. So you can see WordPress. So let's take the subnet, data subnet A and data subnet B. You need to choose it, data subnet B. And the security group as well. You need to put the EFS security group. Let me delete this one. You need to pick the EFS security group, WBEFS. You attach it to the switch of them. So IP address, you leave it, it's going to automatically pick it by itself. And next, I think that's all. Next. If you create it by default, it goes inside the default VPC. And at the end of the day, you won't be able to connect to it. You have that issue trying to connect to it from your side. So I think we are rounding up. So let's check your database results. Why is it creating a reader instance for me on both of them? Something is happening now. I'm wondering what's happening. How are you be creating a reader instance, a two-reader instance? So now let's try. Let's go back to our lab, and I think we are almost getting there. I think we've created our EFS, which is fine. Our database is currently ongoing, so let's so let me just come here. So now let's put the application. So now I think I've explained before the application and all of that in terms of the load balancing, why we need the load balancing, and the reason why you are using an horizontal scaling instead of vertical scaling, and what the load balancer is actually doing here. So we're going to same way we did for database, we're going to do it for load balancer. You know load balancer now. Everybody wants to speak to load balancer, right? Load balancer is what everybody's trying to speak to. So we're going to create a security group for it. We'll call it the load balancer security group, and we're going to use an inbound. The inbound rules is that okay, anybody coming from the internet, they can try to reach my load balancer. I don't know if you get my point. So the load balancer security group is the security group meant for the load balancer itself. So let me just so anybody coming from the internet, the load balancer is the one that will serve them. So we need to check, okay, am I even listening on this particular port? So that's why the load balancer security group is you are opening it to everybody in the internet to connect to you. And just let's come here. So this is the load balancer security group. So you can see I actually in the lab they put my IP. Maybe for me I put it everyone because I don't trust my network. My IP can change anytime. So I just put 000. So this is just actually anybody from the internet will be able to. So once I give anyone my load balancer URL, they should be able to access my application. And my application is listening on which port? Port 80. I get it. So we can still change this guy to HTTPS, attach a certificate and all of that. Maybe that will be the next session and all of that. But typically this guy is listening on port 80. So we can still add this secure certificate manager to it and make it on port 443. But the scope of this lab, this guy is opening on port 80. So the URL that will be given to you, AWS is going to make it a C name or an alias. So from the alias, you can go to your repository and update it, and you consume it the way you like. So we've created the load balancer. That's fine. So the next thing is we are going to create our web server. So our web server will be consuming from where? We'll be consuming from the load balancer. Our web server will be consuming from the load balancer because it is the load balancer that wants to speak to them, right? I don't know if you are getting my point. Let's come here. This is the load balancer. The load balancer is speaking to the. Can you see this is the row? So the load balancer is the one that is checking these guys. Okay, these guys are the one actually running the application. This WordPress instance. These are the guys that are running the application. So this guy needs to check this guy. Should be able to log into them. Okay, are you fine on port 80? Hello, are you fine on port 80? So this guy will be the one to be able to access this guy on port 80. So that's why when you create the security group for the web servers, the source is going to be the load balancer. So the load balancer security group, that's what will be the source for these guys. I don't know if you are getting my explanation.
Yes. Yes,
So, can you hear me?
yes,
we can.
Because this guy, anybody from outside should not be able to call WordPress instance. These are the guys running the application, right? They are the one listening on port 80. What this guy is doing is just load balancing it across these guys, the two of them, this WordPress instance. So if the traffic is coming, this guy take it. Okay, this guy is open on port 80. Anybody from the internet should be able to get to this guy on port 80. But for the traffic coming to this guy, it is only the load balancer that should be able to communicate to the what? To the instance. So that's why the security group of the web servers will allow port 80 only from the load balancer. And the representation of the load balancer is the load balancer security group. So that's why when we are creating the security group of the web servers, we just port 80 and we reference the load balancer. security group to it. So that's the reason why this one was put that way. Are we together? Are we? Are we together?
Yes. Yes. Yeah.
So now let's check our database. This thing is taking time. Why? So let me just let me go to my, I think this guy is fine. Let me go to my EC2 instance and create a new EC2 instance. So we just view how the traffic flows. Once the way the traffic flows. Let me start this thing all over again. Let me. Why is this thing slow like this? So create this guy before, so I don't want. So we'll just go over it together. I will explain all these guys as well. I'll explain. I've done all this earlier. Delete it so that it won't interfere with what we have. I've done. So I'm trying to change my network. I feel like this is slow. Okay, yeah, let's continue. So I think since look good, since we look good, we've created our load balancer, our NFS. So we've explained the logical reason behind the load balancer and all of that. The load balancer security. Let's create our load balancer. So we can see that we have different type of load balancer what we're talking about. So this guy is going to be directing via HTTP traffic. So application load balancer is used for layer 7 only. Layer 7, that's all. So network load balancer 4 and layer 4, yeah, both PLS. So you can use it to terminate layer 4 session. You can see. So now let's create our load balancer. Where is this? So this is the next one, load balancer. Create application load balancer. So let's create. So WordPress load balancer. So it's internet facing. We're going to it's actually facing the internet. So it's IPv4. I'm not using IPv6. I'm not using dual stack means that you can use IPv4 and v6. So now the network mapping, that's our VPC, right? And the security group. So that's the security group of the load balancer. So let's choose the load balancer security. What is the load balancer? I think it's load balancer is and security group. I think is very, very important.
We can't hear you, Lemon. I think the other network is better than this.
Yeah,
this one is.
Can you hear me now? Is it better now? Can you hear me?
Yeah, you can continue talking. We'll be able to access it for a period of time.
Okay. So now, the next one, this is very classified. This is where do you want to put it to? Now, it's all very well. So this is the listener and the reduction. This is where the job answer comes from. This guy
this one is not fine. This net Abi am I the only one having the experience?
I'm experiencing it here as well.
Yes.
I think it's the network.
Okay.
I'm coming. Oh, okay. Let me roll back. As you always say, let me roll back.
It's better. Roll back. Roll back. I think.
Hello, can anyone hear me?
Yes, we can hear you.
Yes.
Is it better?
It sounds better now. Yes, it sounds better now.
Okay. Okay. All right. We go back. So let's create load balancer. At this point, so this is load balancer, right? We've put the security group and it's internet facing. Okay, another thing, pick the zone. I've not picked the zone, so I need to pick the zone as well. So this zone, which is where the load balancer will be pushing this guy on whenever I see the traffic. So we'll pick the subnet A. That's where our applications is, right? And public subnet. Do you understand? Are we together? So these are the availabilities.
Yes,
because the load balancer,
the public subnet.
Exactly where the applications. No. Let me use it all. So the public subnet is the subnet that goes to the internet. Is the subnet where that's not where the servers are. So let me go back. So let me start using it. So this is the public subnet. This is where the server is. So this public subnet, this is where the load balancer will sit because the load balancer needs to speak to the internet. So this guy load balancer is in the public subnet. Is in the public subnet. So let's continue. So what's the guy going to do? He's going to forward it So I receive the traffic report. It's who should I speak to? That's what they call the target group. Who is my target? So the load balancer will just check his listener rule. Okay, well, I'll receive people. What should I take? Target group here. So now let us click on this guy. It's going to take us to a new page. That is our target. Let's see, it should have come up by now. I don't know, it's very, very slow, but so the target group is actually where we're going to now put, okay, why is this guy, when the load balancer get the traffic, where is it taking it to? Is it taking it to an instance? Is it taking it to a ladder? Or is it taking it to, where is it even forwarding the traffic to, actually? So the target group is where we're going to define all those parameters one after the other. I don't know why this guy is slow like this. It shouldn't be. Because I'm picking using US one. But now this is where it can point to an instance, it can point to an IP address, it can point to a lambda function, it can point to another application load balancer, something like a network load balancer, because a network load balancer can point the traffic to. So, but an instance. So you pick the instance one. That's our target type. Let's give it what name should we give? Let's give it WordPress target group. Press targets. So actually, so the next thing is edge check. I told you earlier before that one of the function of load balancer is that it does an edge check to check, okay, hello guy, are you there? Are you up? So it's going to be doing an edge check on a particular port or on a particular part. Most of applications, they have an edge check part, or they have a part whereby whenever you're able to read that part, it means that the application is up and stable. I get it. So that's it. So let's come down. We all agree like before WordPress 1, HTTP version 1. Yeah. So edge check. So the edge check, I think this application is a PHP application. So I think based on the lab, the particular edge check parts as needs to monitor across. Time. So I think the edge check needs to monitor php.info.php. So this is going to be monitoring this kind of edge part on the server. So if this guy is up, it means that okay, servers are up and they are listening. So this is what we're going to put there. Put this guy in the edge check. So do we have any other thing? Do we have any additional check? So I think that's all. So the next thing is I'll just create target group. That's all. So in this part, we can edge check because it's HTTP, you can PS, you can start. So the treasure of the edge check, the timeout, accepting timeout. It's also code, maybe it's 200 and all of that, or 202, or any value you want, you can actually specify it here. So let's create. So we're not registering any targets for now. So we are just creating it for now. So let's go back to our load balancer creation. So this guy. I should be able to pick up the load balancer now. So like if I click on my drop down button, I have it here. And I think that's all. I think that's all we need to see here. So that's all. So now you put in platforms, we're not putting wow. That's another thing. I don't really global. This guy is also a very nice guy. He chooses any casts. So this guy, there's a small difference between this guy and platforms. But this guy, people use it a lot when you have a very, very, very big organization. I think we don't need that guy. Let's create our load balancer. Okay, good. We've created our load balancer, which is up and running. So the next thing is that we're going to create our launch templates. Now let me explain small thing. If you are creating your EC2 instance, if you come here, let me come here. Let me come to EC2 instance. So this launch instance, this is where you put this type of thing. This is when you are creating only one instance. But if you have maybe 5 templates, like a template for you to do with a template whereby you know that, okay, this is the template I'm going to all my stuff. So templates are actually used, especially when you're using so scaling. Yeah. How we can create it. Okay, let's do the name. So let's say WordPress launch template, launch templates. So you can put the description. So website WordPress application. So let's Amazon AMI image. So you can just search for Amazon AMI. Just click on quick starts. Amazon Linux AMI. We can pick this guy. You can pick this guy. This guy is fine. So the instance type, should we put, let's take 2T micro. So we pick 2023 AMI. So instance type, why is not loading? Okay. Let's pick this on 2023 AMI and so the instance type, let's pick the T3 micro. For example, if you are in a free tier eligible, maybe you don't have any credit, so don't use this one, T3 micro. But because I have credit, that's why I'm trying to pick T3 micro actually. But it's not expensive. But everything is costs. So for now, you don't need to put your PPA for now. You don't need to pick your PPA for now. So for the network settings, you don't need the network settings for now. Let us keep that one. The server itself will put the network settings. The thing to put here now is our security groups. Now let's remember all the security groups we've created. All the security groups we've created, there are a lot. So everything is here actually. Everything is here. So long templates. T3 micro. So now we we are attaching, and the one we create for database client, EFS client, and also the server. So we are creating, we have them here. So let's attach them. Where is it? Let's add them, web servers, database clients, and the last one is the EFS client. So that's the three. So let's continue. What next? So the next one is the come to advance. You see what they call a user data. User data is something that will use if you want to bootstrap. You want to bootstrap a server from the beginning. So maybe you want an application, you want to bootstrap. I think I did that. So there is a script here that was used. Let's go through it together. So now you can see that this is the bash script, right? It's a bash. Use your DB name, WordPress. Your user. You know this DB name is the DB name we use right there. So DB name, this is your instance. This one are for the instance. This is the DB itself. This is the DB host. This is the EFS ID. This just like sudo apt upgrade, just because by using that Linux distribution, that's why I call it TNF. It is Ubuntu is going to be sudo apt update. So what are we doing here? We are installing HTTPD, that's Apache. We are installing PHP, PHP MySQL, PHP this one, Amazon EFS utilities. So the next thing, this is batch. We are creating a directory. It's going to create a directory. It's going to create all these guys like Spam. So after doing it, it's going to mount guy on that EFS that we created. You know that way we have our application data. So the next thing is it's going to get there. It's going to download WordPress in a zip file. It's also going to unzip it. It's going to copy it. It's going to copy it from WordPress. The content of it. It's going to copy the content to here. After copying, it's going to remove this zip file. So what we actually and after that, it's going to change the WordPress configuration to our DP. So seed is used to make a change. So any place you see username here is going to change it to database username. So we have a lot of bash commands that are very, very powerful. We have seed, we have org, we have grep, we have a lot of them that they are very, very important, especially seed. So instead of opening this file, start going to this way there is this guy here. So it's just going to search for it global across anywhere where you see the database name here, you change it to this. Change this to this guy. You change this to this guy. So all these parameters they will getting. So that's what this thread is for. Same thing, this thread also use it to update your Apache config file. And this guy is for our health check, if you remember. So you echo it to the php.file. Echo is just like you print inside this file. This guy, you change the ownership. In ownership, this is the username and this is your group. So, and the last thing is that you start your HTTPD and you enable your HTTPD. That's all. This is what this guy is going to do. This script is going to do for us. So, but I think we're starting the master class next week. So I think we'll be able to go into the notes very well. Yeah. So let's copy this guy. Let me copy it to a notepad. And I would edit my file. If I'm coming, let me try and see. So we have this file here. So WordPress, I think WordPress is our this thing, is the name that we use. WAdmin. I use password 12345. password 045. So the EFS, the only thing we need for the EFS is the EFS ID. So let's come here and let's click here. So this is the EFS ID, FS05 something something. Let's copy it. That's the only thing we need. Where's my script? So let's come here. Okay, this is a little bit bigger. Let me find something small I can copy. No. Oh, 57. So just copy it and I'll change it on this thing and I'm sure. So avoid mistake. Let's do it like this. And just copy it right here from here and come here. And just paste it here. So just edit it from here so that I won't just be going back and forth. Password 5. Get first. So the DB hosts, I'm going to copy the writer endpoint. That's what I'm going to copy from the DB hosts. So let's go to the database and copy the DB hosts. So let's make, where's my database? This is my database, and this is the writer instance. So I'm going to copy for the writer instance. You can say this is this guy. Yeah, I think everything is fine. So these are the variables. These are the 3 variables. I think everything is fine here. So if probably you made a mistake here, your application will not be off because you won't be able to mount the EFS to those guys, and also you won't be able to create the database. So if either of any of the two, if there is an issue there, you'll be having maybe 503 or 504 gateway error and all of that. So you must ensure that if your variables are correct, you don't have mistake in terms of your variable. And that's all. So let's create. That's all. Let's create a launch template. So we are not doing anything now. We are just creating templates. Templates, just templates only. So the next thing now to do is that we're going to create our web servers using the auto scaling group. So that was the next thing. Let's check. So as I've said before, I think we've explained what we call the auto scaling group and the everything. So now let's create. So it is quite sequential. So what you have to create some templates before you go to your auto scaling group. So let's come to the auto scaling group here. Let's view this guy. So this is this guy and auto scaling group. So let's create auto scaling group. So so WordPress ASG. So which launch template are we using? The one that we just create now. Now let's come up next. So the network WordPress. So which availability zone are we choosing? Hello, are we there?
Yes, we are here.
So which availability zone are we choosing?
It should
Are we
be
choosing
public.
it should be the public, Abby?
Yeah, public subnets. Yeah,
Are you sure?
I'm not sure.
For our web servers, no, it's private. It's only the load balancer that will be in the public. So for the web servers, we are still using a private subnet.
Application
Let's
subnets.
come here. Let's come here.
Mm.
Application subnet, yeah. So now
Mm.
let's come here. You can see this is the guy. So the application load balancer is in the public subnet. So the application server, the NAT gateway, all of them are in this public subnet. And the reason, and the application subnet is in the application subnet. The application, the WordPress instance, is in the application subnet, which is the private instance. This guy cannot go to the internet. It can only incoming call from the internet cannot go to it. It can only go outside the internet using the NAT gateway. So this guy is expected to be in the private subnet because we don't want to expose it to the public. So anybody that wants to see this guy should come through the application load balancer. So that was what I was explaining about the security group of this guy connecting to the WordPress instance. So anybody coming from the internet, you can see the flow here. When it gets to the internet gateway, it takes them to the load balancer. From the load balancer, it now takes them to the WordPress instance. So the WordPress instance needs to be in the private subnet because, and the reason why we need the NAT gateway is that you know all those pseudo apps that we are doing. If this guy doesn't have access to the internet through the NAT gateway, it won't be able to pull all those updates, all those downloads, all those guys. So that's why the NAT gateway was here. So let's continue. So we're going to pick application subnets, which is the private subnets. And the balance effort is based efforts, the distribution. So next, attach to an existing load balancer. I think we have a load balancer already. So we take it. So we are not using VCP Lattice. VCP Lattice is service to service communication in AWS. So we are not using it. We are not using it at all. So VPC service is another thing entirely on its own. So now we need a check now. Let the guy do a check for us. So the period, 300 period is fine. This period is fine. So how many capacity now? Our desired capacity, let's put 2. So minimum capacity is 2 and maximum is 4 at 21K. So this is the minimum. So by default, this guy, when this guy spins up, he spins up 2 instances. But we're going to put a kind of a scaling policy. Scaling policy means that, okay, when you see that maybe the CPU is 80% or the memory is 90%, or you create another one. I get it. So that's what they call the tracking scaling policy. The scaling policy shows us how this guy will behave, how he's going to do that kind of horizontal scaling. Okay, what are you monitoring to scale? Are you monitoring the CPU? Are you monitoring the IOPS? Are you monitoring the network bandwidth? Different kind of parameters can be in your scaling policy. So let's what should we use? Metric, let's use CPU, target value, let's use 18. When the target value is 18. So an instance ramp up is that, okay, when the guy reach 80 like this, you need 30 seconds to start bringing up the order. So this is, if you are trying to, I'm saying it again, if you are planning to write the exam, architect associates, you must know all these things. It's a no-brainer. You must understand it very well because they will ask questions about it in the exam. So this is the scaling policy, and this is our minimum. So at rest, we'll be having 2. But when this guy noticed that the CPU has reached about 80%, it should create it to 4. It should increase it. So the instance maintenance policy, maybe you want to, this is how it behaves when this guy, he wants to do that kind of auto scaling. Should it launch before terminating or launch and terminate and launch and all that? This is called the maintenance policy. Maybe you want to shut down the instance and all of that. So we are not doing any additional capacity reserve and all of that. I think everything looks good here. So I think everything looks good. So next, we're not adding a notification next. So let's review everything together. These are application subnets, these are load balancer, target group, this ELB and all of that. So let's create auto scaling group. So it's gonna take a while. So once we start creating auto scaling group, if I go to my EC2 instance now, we would see two instances coming up. Like it looks like somebody's trying to, you can see two instances are coming up already. So, and you can see they are part of what? They are part of an auto scaling group. So they are coming up already. So it might take a while for them to come up. It's actually in the initializing process. So let's wait for a while for it to come up. And the last thing is we'll go to this guy also is, yeah, these are auto scaling groups. So auto scaling group is the one that will create those guys. So if you have your launch template and you've not created your auto scaling group, you're actually fine. Nothing is still happening. So an auto scaling, the launch template is very interesting. You can even update it. That's version 1, version 2, any version you want. So I can just go to that template. Maybe I feel like, okay, let me add some things again. I can just go to edit some things again and create a new image. So when I want to use a new auto scaling group, I can use that updated image to create my instance as well. So let's go to the load balancer. Let's go to the load balancer. Once we have the load balancer, I think it's running now. It's running, but still, I think we should have something we call 2/2 something. This guy has to initialize, and let's calm down a bit. Yeah, I'm thinking that I'll be able to do that to some. So this is the load balancer. So let me just let's see. So this is the load balancer, and this is the network mapping. This is so. But if you want to see how the edge check is fine, so you can see it's LD, but you can't even see it very well here. So let's go to the target groups. From the target group, you'll be able to see the edge check. But this is the URL we will try to reach. Let me see. Coming. So this is, you just copy the DNS name. This is the DNS name. So this target group, you'll be able to see the LD ones and all of that. So it's just trying to come up. You see two LD here. Oh, we've not applied target. Okay, we have targets here already. You can see LD. So we have two LD here. So this is my load balancer. This is my target group. So you can see the target group are fine. So it means that we are good. So this is the load balancer. Let's copy the DNS. This is a record. So maybe you, in your company, maybe you now have your own website name. You have a domain name. You can now do like an alias and map this guy to your www.sulaimanwordpress.com. So let's see if this guy comes up. So here we are. So we have our application ready. So you put your name, maybe let's get your name, sites terminal. let's see, my man, password. Sulaiman 2025. It's very weak, don't worry. Confirm with password, your email. Yes, so end of the you share. This shows that your email is up. Your website is up at gmail.com. Everybody that is very used to just do this, I just put it somewhere here so that I won't forget. So you have your website already. So it's installing websites. So login, Sulaiman, and we are good. So you can see that all these WP admin, all those guys are actually what is on the EFS. So it is when the way I log in now, I'm interacting to my database. It's putting my records in my database. But what is loading the content and everything is the EFS. You can see the appearance, the post, everybody. So you can, if you can even take up if you want to as a side something. If anybody wants to create a WordPress, you can do it for them. You be the one that will manage it, and you will know how you're going to manage your cost with AWS and all of that. So this is how a WordPress looks like. So the only thing you will need at the end of the day is to make this one, put a certificate there, and use an alias record to manage domain name. I think that's all. So is there any question?
Yeah, thank you, sir. Before we get to the certificate, the question I have is that we deploy EFS on the data subnet.
Okay.
EFS, we deploy it on the data subnet. So I was expecting that this content will be stored inside the EFS.
Yes.
Then,
yes.
However,
the content is on the application data. Sorry, continue, please.
Okay, so I'm wondering, I'm looking at how are we able to access it, because we are actually able to access the web now. So how are we able to access it, even though it's actually behind the NAT gateway? And from NAT gateway, we are not supposed to be able to access whatever is inside the NAT, behind the NAT gateway.
Okay, this is it.
So everything is just confusing.
No. This is it. So you can see that this guy, this is EFS mount target. EFS has already created a mount target in this subnet, in this data subnet. It's not like a mount target, just like an endpoint. Okay, once you so the only thing the WordPress needs to do is just to call this endpoint to this data subnet. It's going to refer them to the EFS. That's why when we are mounting it, we create a network access and put this data subnet there. So it's going to put a mount target on this data subnet. And these guys, they are in the same VPC. They'll be able to communicate to each other because they are in the same VPC. It's not going to the internet. So this guy will just call the EFS mount target here. And this guy also will call the EFS mount target here. I don't know if you get my point.
Yes, I get the point. Then the other one is the instances that we were able to launch with our launch stock templates and not to scale. What is now in that subnet? That is okay. We have, yes,
this instance, right?
What is inside
that's
the
where
data?
We put our application. Exactly. What we have is Apache. That's the web server. You know, this guy is, this WordPress is a lamp stack. Lamp stack means that what's the name? The Apache, like a lamp stack has, let me, I'm coming. Lamp stack. So can you see? I give the lamp stack. WordPress is actually a lamp stack because it has Linux as the operating system, Apache as the web server, MySQL as the database, and PHP for the programming. So the web server is what that is installed. The Apache, that web server that is listening on port 80, that is what that is installed on that on that instance.
Sorry,
Because at
I
the
didn't
end
get
of the
that.
day,
Which one is stored in the application subnet?
the
I
the
didn't get that.
Apache is the one that is installed on the application instance. The app instance is this
Okay,
Apache.
okay,
If we come here,
okay.
let's
Apache is installed there.
come
Then what is now inside
Yes.
the EFS?
EFS, now I'm coming now. I'll show you now. I'll show you. The EFS, this everything that happened is inside this bash script. You can see that EFS, this is the lamp stack. This is you install the first thing you install HTTP. This is Apache. This is the PHP programming language, and this is EFS mounting utility tools. So the first thing is that you create a folder. You create a mount point. I get to me. So that you create a folder first. You create a folder on that EC2 instance. This is the folder. All of them you create a folder for. The next thing that you now mount this folder to this EFS instance. So anything that is on this guy is the same thing on this EFS. I get me.
Yeah, I'm getting it.
So now you now come down and what? See, you know this WP content. This don't forget this folder. WP content. So you are the one that creates it, right? So now you install WordPress. This is you see it with this folder. Yeah. You install WordPress. After installing WordPress, you see it to this guy. Install WordPress. You unzip it. This is unzip. Then you now copy all the content here. You copy it, like you dualize it. Simply just to maybe to copy something. So once you copy it, they now remove this WordPress. So you now come down. You now copy everything that is in WordPress. I get in everything that is in WordPress after it. Everything in WordPress. This is an asterisk. This shows that WordPress is a folder. So anything after this folder, I'll copy everything and put it in this folder.
But if you want to edit this guy, let's say there's a mistake, I want to edit it. How do we access it?
You can access it. You've already done another thing you can do is now create another launch template, update what you've done, and use that new template to create another server. Because you didn't attach a key there. That was why it was there.
Okay, let's say we have a key here. Let's say we have a key here.
Yes, you'll be able to access it now. You'll be able to access it. Yes, but you need to be. Maybe you now need to use a Bastion host because you know those servers are not on the internet.
Yes,
so you now create a Bastion host in the public sub. From there, you'll be able to take instance endpoints server. And
because I think I tried something like that, but when I check this application subnets. Okay, maybe I didn't know the directory, maybe I didn't know the right directory to share.
So this directory. So all the content on this WP content will be actually on this EFS. So anything on this EFS will be on this guy. So if you update anything on this folder, it will be on this EFS ID. And all of them will be taking it from the EFS ID, just like a shared file system.
Okay.
So these are at the end of the day, this is Apache. Now this is the Apache guy. This one running for 18, and you are good.
Okay, sure.
So this guy is actually like a lamp stack. We have lamp, we have men, there are 4 like that. So that's all for today. It's been a very long day. I didn't know that it's going to take up to this time. So thank you all for this. So